How's it going? Can you all hear me okay in the back? Can I have my slides, please? There we go. All right. Thank you for the kind introduction. So as was stated, my name is Kevin. I'm from the Seattle area in the US. I currently work at FutureWay, where I'm leading Project Robius, which I'll get into a little bit in the next couple of slides. But mostly today I'm going to be talking about Robrix, which is our new app. And that is mostly currently a Matrix client, but it will be so much more in the future, written purely in Rust with zero platform-specific code, but it supports all major platforms. Right. So with a single code base, we can have many different platforms supported easily, thanks to the underlying layers that both us and other teams are working on. These are some old screenshots as a teaser for the new version of Robrix, which I'll show in a second. But before I get too much into it, I'd like to back up and give you a little bit of insight into why we're undertaking this project. Like, why are we interested in Matrix? Why are we interested in writing a client? And why is the larger Project Robius a thing? So the main charter of Project Robius is to create a multi-platform aptive experience entirely in Rust, where you never have to delve into other languages, bindings, anything like that. This would allow developers to leverage the robust, safe, and performant ecosystem that has become inherent to Rust, which a lot of people really enjoy. As I already mentioned, you don't have to deal with other languages or environments, like complex bindings to different app dev toolkits. And you never need to write a single line of platform-specific code, which is really convenient. You can stay in your flow state, stay focused, and be productive in Rust. Okay. And then our secondary concern is we'd like to make mobile platforms specifically a first-class concern. So there's been a lot of projects. The presenter from Huawei this morning, she mentioned some very exciting work on mobile Rust, and we are also working towards that. And in fact, we hope to support Open Harmony in the future as well. But typically, if you look at mobile throughout the history of Rust, it's been one of the sort of a second-class platform. So we'd like to fix that. So to give you a little bit more background, Project Robius as an app dev framework is entirely open source. It's decentralized. We have a bunch of different contributors from all over the globe and generally community driven. Although I and some folks on the MakePed team do a lot of the heavy lifting recently, but we have recently, we have recently attracted a lot of new contributors, which I'm immensely thankful. Everything is entirely written in Rust, as I already mentioned. But why? Why do we want to do this? All right. There's already a bunch of great Rust UI toolkits. If you're familiar with the website, Are We GUI Yet? Or all of the other different incarnations, you may recognize some of these Rust frameworks up here. These are actually very great projects in and of themselves, and they go a really long way to making our job easy. However, there's actually a lot more to developing a fully fledged app than just drawing a GUI. Right? So all the different little platform features that you need to integrate with and expose in ideally a safe and ergonomic and easy to use manner into the app dev layer in Rust, those things are generally missing from these UI toolkits. And that's through no fault of their own. That's just sort of the scope. So the scope of Project Robius is all about addressing all of those missing holes, the gaps in the code, in the UI toolkits there, and allowing them to flourish while allowing the app developer to use all of the nice little platform features that they would expect. So the next question you may have in your mind is, why Robrix? Why are we writing another Matrix client? There's already a bunch of Matrix clients, right? Well, so actually this started in sort of a different manner. Initially we wanted just some sort of key app that would drive the main development and help prioritize which parts of Project Robius we wanted to start with. We initially did some brainstorming and said, what sort of app is highly demanding? So in the modern era, a lot of these chat clients are quite demanding, right? You have multimedia chat, you have location access, you have integrations such as mini programs in WeChat. You can have a whole host of different very powerful and very demanding features inside what previously would have been a simple chat client. So yeah, there's some of the other platform features I'm alluding to, but more specifically, why did we choose Matrix? So I think Matrix shares our values. Our values already mentioned: open source, decentralized, community driven. And of course, we want to do everything in Rust. And Matrix has somewhat recently, over the past couple of years, started transitioning to using Rust to implement their main SDKs. And now they are transitioning all the other platform clients to use and rely on that Rust SDK. So that's really exciting. I just got back from the first Matrix conference in Berlin, actually, and I was thrilled to see a lot of different Rust-related work there. So I think the future is bright for Rust and Matrix and Project Robius together. Oh, okay. So then we thought, after we had this initial kind of motivating factor of using Matrix or using a chat client as the driving force behind Project Robius, we said, you know, we can actually do quite a bit more with this than just a basic chat client, right? We can go further, right? The obvious approach is, can we make a better Matrix client? Can we make sort of a super client that can do a whole bunch of other things? And I think that you'll agree we can, once I show a quick demo. And we can, you know, kind of address some of the issues that people have had with existing clients. Not to say that they're not great in their own right, but, you know, there's additional features that have been clamored for over the years. And then can we go beyond Matrix and look at other next-gen internet service, things like federated services across the Fediverse? Specifically, we like to kind of bring the needs of the open source community and the open source developers into focus, and combine things like Matrix, ActivityPub, perhaps local AI LLMs, which I'll discuss in a moment, and a variety of other source code tools, into a single centralized app that makes it really easy to be productive without leaving that context of the app. Okay. And then, of course, the meta goal here, the main project idea is that if we can create a really nice app, this makes a very strong case for app dev in Rust, which is something that, for some reason or other, there is a lot of commentary on the internet, like in Reddit forums and other places, where people, I think, mistakenly think that app dev is not possible in Rust. So we'd like to show that that is indeed possible. Okay, so let's talk about some other goals and kind of our roadmap for this project, both Robrix and Robius. So our primary goal here is to implement everything underneath the app. So all of the stuff underneath the blue layer that you see at the top, right? We're leaving the UI work to the experts, right? Megpad, Dioxys, all those other ones that I listed previously. And you know, we contribute to that, but that's not our main focus. Our main focus is everything else, primarily these platform abstractions here in purple that you see on the right side, right? I'll talk about the concurrency a little bit more, but generally this is kind of the charter of Project Robius to make this possible. I'd also say that this is just the runtime components. There's a lot of other build tooling, like packaging releases and, you know, dealing with assets and things like that, manifest dependencies, entitlements, and permissions. That isn't pictured on this slide, but those are also under the scope of Project Robius. So what does this look like specifically for a complicated app like Robrix? So we actually need to delve into the application itself too, because, you know, I'm the one writing this application. So we do need to dig into the blue layer now, not just the underlying layers, excluding the UI toolkit. Right. So what we've done, we've basically decided that Robrix is kind of the guide to how we prioritize our work in Robius. For example, if I need to access location because I want to share my location over the Matrix transport with other people in a Matrix room, I need to go ahead and implement a location abstraction that works across Android, iOS, Mac, Linux, Windows, etc. Right? So that helps prioritize our different project components. And then also, writing the app itself is a good way to dog food our componentry here. Not just the UI toolkits, but we're definitely doing that, stress testing them, as I'm sure some people here will attest to. But also the other components and the concurrency abstractions and platform abstractions that are pictured here. So some of our meta goals, I think, are relatively straightforward. We'd like to have well-structured and well-commented code. I think that's sort of a given. But we want this to serve as sort of a template for complex apps. So if you wanted to know how to you know, implement an application fully in Rust using these components, you could start with this, take it, and modify it for your needs. And then ideally, we would also attract more upstream contributors so they can contribute back to the project. We're also working to publish some detailed walkthrough guides. We had some workshops on MakePad this morning, and we have a variety of other workshops planned for projects that are adjacent to this. So I'm excited to see some of that come together, but we do plan to do more in the future. Sorry, I'm not sure why those things don't line up, but it's okay. And then, you know, just demonstrate that this thing is actually usable and that, you know, you can, in fact, write applications in Rust. So our roadmap is sort of in 3 stages. This is for Robrix specifically. The first stage is to kind of publish an initial version of the app that offers fundamental kind of basic matrix client features, the things you'd expect, like being able to send and receive messages, being able to log in, having your app persist the data, supporting end-to-end encryption so you can view encrypted rooms, right? And then, of course, we'll do everything necessary to support that while we continue to build out the rest of the app dev ecosystem and contribute to those UI projects as needed. Stage 2 is kind of working on a better matrix client or a super client that can serve the needs of power users. So this would be, at a bare minimum, reaching feature parity with other clients, including those administrative features like joining or creating rooms. And then having a more interesting UI designs where we can run on mobile and run on different screen sizes and different form factors. And then perhaps also introduce something like local LLM models into the mix. And I'll preview that a little bit later. And then stage 3 would be opening this up and exploring other next-gen internet services, like things in the Fediverse and other open source services beyond just Matrix. Specifically, cool things like what the folks from the Open Wallet Foundation and other decentralized identity providers are doing. We want to allow you to log into Matrix or other services with that. So Robrix can act as sort of the initial experimental testing ground for that. All right, so let's dig a little bit more into stage 1. So the roadmap stage 1 here is actually mostly done. I'm happy to report a little bit early. I'd hope to finish this by the end of the year. And thanks to some outside contributors, we've almost finished everything here. So that's our feature status tracker, which you can always see from our GitHub page, which I'll link to at the end. But yeah, as a basic overview, and I'll demo some of this later, but as a basic overview, we have login, rooms list using the new sliding sync protocol, and even the new simplified sliding sync protocol. Obvious, basic messaging, annotations, which is reactions, replies, rich text formatting, so you can see, HTML or Markdown formatted messages and things like that. I literally just this morning published an alpha version of Robrix. There are still a lot of things to be done, but you can find that as a release on our GitHub page. That's sort of just to show that we also have this build tooling in place, which was something missing in the Rust ecosystem for quite a while. But we do rely heavily on folks from Crab Nebula and the Tori project, so thanks to them for that. I've also contributed to that as much as needed to get those to work nicely for Robrix. And we have also completed platform support. So here's all the different platforms that we support and the hosts on which you can build those target platforms. Then stage 2, which hopefully would be our beta release sometime early next year, would be all these other administrative functions and auxiliary features like SSO login or the Matrix authentication service login. Additional information about rooms or about users, preference panes, these sort of things. So we have some of this already implemented with some of our sister projects, the Motion Moli project, which is a local AI LLM runtime. And we have some of these partially done by other contributors, but they're not yet merged into the mainline. So basically, these are things that didn't drive the development of Project Robius, so we sort of sidelined them for a moment, but we hope to get to them very soon. I think after this point, you'll have Robrix will be, a matrix client that you can actually daily drive and use in a regular basis. So I'm already using it as of last week. So a lot of this is very new, but hopefully within the next few months, you'll be able to pick it up and use it just as you would Element or any of the other major matrix clients. So I just wanted to highlight some of the rather significant implementation and systems challenges we've faced in getting this basic stuff to work. It seems basic, right? On the surface of it, it's just a chat client, but under the hood, there's quite a lot going on. So I just wanted to highlight some of that. All right. Obviously, the main charter of Project Robius involves exposing and abstracting platform APIs and OS services, which is one of the hardest things to do. We also need to deal with multi-stage builds and things that Cargo and Rust C don't care about. They're not under the purview of those tools. And we have some collaborations with other folks. Specifically Cassandra, who's presenting a work, I believe, maybe now or later this afternoon, about her build tool Quake, which will help us kind of steer Cargo in the right direction and build these tools, build these apps and release packages more easily. We need, as I mentioned before, we need to sign, bundle, package, and distribute these apps, which is a whole separate ordeal. And all of these need to be done across many different platforms in the right way such that, you know, the vendor, like Apple or Google, will accept a Project Robius app on the App Store, right? So I've experimented a little bit with this so far, but there are still some challenges to overcome. I also alluded to this a little bit. We want to make it easier for an app dev who may be less experienced with system concepts, and specifically some of the difficulty of using Rust in an async way with the sync way and all these different concerns about memory safety and concurrency violations. We want to simplify that and make it easier for a front-end app dev who doesn't have experience with that to come in and use Rust without getting bogged down by all of these complex details. And of course, we want to submit not just one toolkit, although currently I'm using MakePad, but we'd also like to support others. Among the many are the list that I showed up front, but you know, at a bare minimum, things that are native, web-based, and perhaps others. So this is kind of a short list of some of the platform abstractions that we've been targeting in Project Robius. Just to breeze through this real quick, since I don't have time to get to all of them, here's our rough status report. As sort of a colored diagram. So yellow is things that are partially done, green is things that I would largely consider to be complete, and most of these are being used in Robrix or in other apps that rely on Project Robius crates. So we have thoroughly tested most of these things, and I'll demo some of these today. So some of our crates, which is just a Rust project that we've contributed to the ecosystem and being used in real apps, are these here for things like getting your current geolocation, storing something in an OS managed secret storage, like a keychain, doing things like abstracting the Android state that a UI toolkit will own, you know, the JNI environment, the main Java class, those sort of things. Being able to build Android tooling as part of a Rust build process in the cargo build script, and then accessing project directories, opening or sharing intents and links to other apps, and then a whole bunch of other things, authentication being a default URL handler, and then packaging stuff. We've also made significant contributions to MakePad, but I also want to just call them out because I think they've done a really great job in supporting my needs, and I'm very needy when it comes to this app. So I think that we've come a long way over the last year or so, contributing to these various projects. As I mentioned before, our target platforms are the main, you know, suspects: Mac, Linux, currently just Debian and Arch-based ones, although we do plan to support others, Windows, and then the mobile platforms. Very soon, we hope to support OpenHarmony, and there are some other presenters giving talks about this, supporting this for MakePad in some sessions today and tomorrow. So I'm very excited to experiment with that myself. Web and WASM we do want to support, although currently there's some limitations there with the Matrix Rust SDK not building for WASM, I believe, or having some features not available yet, and then perhaps others in the future. All right, so let's go for a quick little demo. Hopefully everything is still connected. Can you see this? No. Okay, here we go. So this is just a basic view of Robrix. All right, good, we're still connected, that's nice. So this is what you get when you first log in, just a list of rooms. It's nothing too complicated yet, but pending internet availability. One thing I wanted to highlight, which is a big kudos to the MakePad team, is just how fast you can make this, right? So you can see, you can scroll easily at 60 frames per second. I don't know how that shows up here. Yeah, pretty good, if not 120 and beyond. So we're ready for these modern mobile devices that have extremely high refresh rate screens, and all of these gaming monitors that some of our targeted power users may want to use. So we have basic support for most things. You know, you can draft a reply, right? You can navigate here and there. You can view information about users. So all of these things are things that we've contributed to MakePad or asked the MakePad team to help us implement. In addition to this, we have, I think, a very fast startup time. So this is a bit risky, but if the internet holds out, we should be able to, I'll just start it. It should be like mere seconds. Yeah, it's very fast. So the latency you saw on the login screen is internet-based, but everything else is quite fast. Some of these rooms are encrypted, so we also do support E2EE for encrypted rooms, and device verification as well. So there's a lot of other things that I could demo. One thing that I think is quite cool is a new UI that we had contributed by Julian. He's another guy who works on MakePad and some other projects. So I'll make it large, and then we can start. So these are my private matrix rooms, so try not to read too much into them. But we can utilize all of this wasted space here, which is something that I previously have complained about from other clients. So we have sort of like a desktop IDE feel on larger screens that can support it. And you can, do anything you want with these. You can split these in many different ways. Right? And we can resize and do a bunch of different things. We can move them, and then we can interact with each of these independently. So we have this really nice way to, make you more productive without having to switch context over and over. I know this is a basic thing, but I think it's important to show that, Rust UI kits and Rust apps can actually achieve something like this. And we're retaining the performance, right? We still have incredibly fast scroll times. We still have a very nice implementation of positional stability. If I can get to the top, we have quick loading. Yeah, you saw that, see? With continued motion. So it's everything you would expect from a modern chat client. And most of this stuff was actually implemented in the last couple of weeks. So it doesn't take too much effort, I don't think, once you have the componentry in place. Here's our Robrix channel, which you can come join and chat about this app with us and file your complaints. And yeah, so that's a basic overview of Robrix. So one other thing that I'd like to demo here, I'll close this out so we can just open a new copy. We also have an adaptive or responsive UI, depending on how you like to call it. So here, let me open. Okay. As we change the view, and this is especially important because we want a single code base to support multiple platforms, as we change the size, we can change the view structure here. Right? And you can see this is what you'll get from Android, right? And just like you would expect, here, let me flip over to the Android studio, right? We have, that's a little bit, here, let me make that a little bigger. Okay, just like you would expect, you have the same sort of performance, you have the same interaction paradigms, because it's a single code base. So this makes it, I think, really easy to write an app that can respond to all the different form factors that it may execute on. Oh, sorry, I didn't realize that was over here. There you go. And it still works just as you would expect with nice fast scrolling. And this is on my 5-year-old MacBook. So a newer machine should have no problem at all, right? You get all the same paradigms. You get everything that MakePad provides. You get everything that Project Robius provides across all these different platforms. We can also do this for individual views. So just as a demo, not that you would necessarily want this, but you could perhaps not want to have the room sidebar take up so much space. So you'll notice here, as we're shrinking it, we've decided this is not quite enough room for you to display a preview of the latest message. So let's go ahead and hide that. And then if you continue to further shrink it, you get the same sort of thing you would expect. We can only show the icon, right? So all of these sort of features that you would expect from a modern matrix client, you get with Robrix. Okay. So there's a lot of other things I could demo, but I think that's good for now. Okay, yeah, we're back. So there's quite a few systems challenges I could elaborate on. I don't know that they're necessarily appropriate for this track, but one thing that I wanted to highlight is the difficulty of dealing with mixed execution contexts and specifically different forms of concurrency, right? So when we had initial contributors starting to write some of this stuff, you might have this sort of code where you're trying to draw a view that has an image, right? You're trying to draw a message that contains an image. You need to fetch that image and then wait for it to come in on the wire and then display it at some point. All of this is asynchronous inherently, right? The Matrix SDK provides this sort of function. I hope you guys can see this, which is async, noted by the await here. But note that here we are not in an async function. We are in a regular synchronous function, the drawing code, which runs on the main UI thread, right? So what happens when you try to do this? Let's say you were a first-time app dev and you didn't really know what was going on, and you're not really familiar with threading or concurrency or asynchronous execution. What would happen? You'd get this sort of confusing, potentially confusing error message from Rust. And while Rust's error messages are very good in general, you might not have the experience and the background to understand what this means, right? So as I said already, the including function is not async, so you can't call async functions. That's obvious, right? I'm sure everyone here is bored with this, so let me move on. So the next approach this new app dev might try is to actually spawn an async task and call that function within the context of that async task. Okay, that's fine, no problem. We do it. This time we don't get a compile error, we get a runtime error, which is worse. And you get sort of a cryptic error about this not being called from within the context of a Tokyo runtime, which is the async runtime that Matrix uses, therefore the one that we're using. And you may not exactly know how to fix this, right? So I think this illustrates sort of a non-obvious problem that people, especially newcomers to the field of app dev, will encounter when they start dealing with these mixed concurrency conflicts, right? I think most people would agree it's fairly straightforward and obvious that you don't want to block, or you want to minimally block the main UI thread as much as possible, so you keep a responsive, low latency UI. Right? Obviously, you don't want to invoke any blocking functions, especially if it's something where the OS may block that native OS thread. But I think it's also a little bit less obvious, and if you want maximum performance, you ideally don't even want to call async functions on the main thread, right? Because those could also block depending on what that function is doing internally, right? So the same issue can happen on other threads, but we mostly care about the main UI thread because that's the one that gives the proper feel for the UI experience and what the user actually sees. All right, so the key takeaway here is we don't want to invoke any blocking functions, even supposedly non-blocking async functions on the main UI thread. And as you saw in the demo, that actually gives you very high performance. So I've gone to great lengths to avoid this in my own code, but once I took a step back and realized that this would be incredibly hard to replicate for a newcomer, I realized that we should probably spend more time, improving the ergonomics of mixed concurrency execution here, specifically for app dev, which has, I think, a little bit different constraints than something like a backend web server. Okay, so one of the solutions, I think you can probably see where this is going, is that you would call a synchronous function, which then will submit a request, and I'll breeze through this in the interest of time. But you would call a synchronous function that will submit an asynchronous request that is received by a background async task, which actually has the proper context to go ahead and invoke that Matrix Rust SDK provided asynchronous function. And then that will actually do the work. It will fetch the media or whatever else you may want to do. And then once that request has been handled, it will then inform the main UI thread that something else is ready, and it should refresh itself, or it should pull some cache, in this case like a media cache, to get the picture that just come down the line. All right. So we use this pattern a lot for backpagination, which is scrolling up past the history of messages, sending messages, and basically everything that the Matrix client is doing, because inherently the Matrix SDK itself only exposes asynchronous functions, which is something a little bit difficult to deal with when most UI toolkits, at least in Rust, do not expect async execution on the main thread context. So this led me to brainstorm what a generic solution for this might look like. And it would be something like this, right? We have the main UI thread, which issues those non-blocking requests to background functions. Those can either be background OS native threads, or they can be a background task, which is running in an async pool, like a Tokyo runtime. Excuse me. And then, as I said before, the app logic that's calling the Matrix SDK function that's async will then go ahead and do that as a direct function call, and then issue that result either back to a background thread or back to the UI through something like a cache. Right? So there are a lot of other tricks I use to get super high performance, which I would like to abstract and provide as libraries or frameworks to the next generation of new coming app devs in Rust. This is just one of them. I can give you another example if we have time here in a moment. But this is kind of the main idea of the concurrency challenges that are revealed when you start writing and dogfooding a real app. So another example of this, which I think is much more challenging, is device verification. So device verification is Matrix's terminology for basically verifying you are who you are on a different device. So let's say you signed up on Element on your desktop, and then you want to receive encrypted messages or view encrypted message history on your iPhone, right? You have to verify yourself. So that's how we do this with device verification. And this is just a more complex version of what I just showed. Rather than fetching something, we have multiple different bodies that need to be synchronized in lockstep. Not only do we have the devices, the on-device componentry here, but we also have the other device, which needs to communicate with us and synchronize over the internet. All right. So the first step in doing something like this, actually, I think it'd be better if I just showed you the demo first. So let me do that real quick. Okay, so I captured a little video because this can be a little bit glitchy. Oh, we can't see that. Oh, sorry. Let me stop my presentation. No? Okay, there we go. So I captured a little video here. Can we all see this? Nice. Okay. So this is, oh, excuse me. This is Robrix on the left and Element on the right. And what I'm going to do is, you can see here on the bottom left, I don't know if you can see that here. Let me move things over. Okay, that's probably better. You can see here on the bottom left, we have messages that have not been able to be decrypted because we haven't done verification. So you can't read this until you actually perform this device verification step. So the first thing we do is we go to Element and we find this session. We click Verify Session, at which point a modal pops up, and this has been registered behind the scenes. And then it takes you through the interactive user interactive verification procedure, which is basically matching emoji. We don't yet have support for emoji in MakePad, but if you confirm and everything goes well, then you begin to get the encryption process, the decryption process, excuse me, begins to run in the background. And okay, once I clear the update, you can see that some of these messages will begin to decrypt in the background. Yeah, there we go. So this is some history that was sent in an E2E room that I accepted and did before this new device had been logged into. And oh, I gave away things a little bit. Okay. Yeah, so this is basically a more complex version of the concurrency challenge I just showed, right? First, you start off by registering this verification handler, which happens on a regular background thread. Once the application has started up, that's one of the many things you do to configure the application. And you do that with a direct function call toMatrix. That's non-async, so you ideally should do it in a non-async context. And then when a verification request comes in from the other device, right, we receive that in an async context, which is required because this is an async function that awaits this request. And then we need to inform the user via the UI main thread that this has happened. All right. So we do this with one of many different channels or different types of inter-thread communication. And then we need to send the user's response, which is the button press, back to the asynchronous task so we can tell the Matrix SDK and the other device, hey, you know, did we finish it? Did we not? What happened? All right. So, okay. And then we'll send that out to the other device through the SDK. Again, this is asynchronous, so it can't be done on the UI main thread. All right. And then we'll wait for the other device to respond. And you can see where this is going. Then we need to give a status update to the user so they don't just think that something has failed and you have, no response from the UI. And then at that point, the user should look at both of their devices, confirm whether or not the emoji match and the short authentication strings match. If they do, all good. If they don't, you've been hacked, so that's a problem. And then we send that confirmation over to the other device, wait for their confirmation, because both devices need to do it, and then finally we've succeeded, right? So at that point, we alert the UI, the user via the UI thread that this has happened, and we also kick off a bunch of requests in the background to go through and decrypt the previous message history that we could not decrypt before we got this verification. So this is quite difficult to implement, and I would love for future app devs to not have to deal with this degree of complexity. Rust has a lot of great things about it. One of the things is, which I'm not using yet, but one of the things is that you can do something like correct by construction and compile time type safety checks that would allow you to implement this in a series of separated but synchronized finite state machines. So that's something that I would like to do there and make this a little bit easier for someone to implement just by defining those states, defining the transitions, the edges between the state nodes, and making it a little bit easier. So if you look at the code for this, I don't think I have time, but if you look at the code, it's hundreds upon hundreds of lines of code, and this should really be much simpler to do. So in going through this process just around a month ago, This is exactly the sort of thing that helps inform our future work, and is one of the reasons why I begin to, I think, enforce the importance of concurrency abstractions and dealing with multiple different execution contexts, sync, async, and main UI thread. Okay, so right, I just said that. All right, so I'm a little bit short on time. So as a summary, that was stage 1 and some of stage 2. I bled over a little bit, but there's still a lot of challenges that remain, concurrency being one of them. And we plan to address those challenges in the coming months, hopefully most of them by the beginning of next year. But so far, we have developed a lot of key feature and platform abstraction crates. We have published a first alpha version of Robrix, well, at least published to GitHub. And we have written some walkthroughs, but not as many as I would like. So let's look at the stuff that is maybe more relevant to this crowd, what we'll be doing in the future. So as I already showed, we want to have sort of a matrix client for power users where you can have multiple different contexts available, multiple different rooms. You can show multiple different things at once in sort of an IDE-inspired UI. We have not yet reached feature parity with existing clients, but these things are relatively easy. It's just a matter of time. We do have, ahead of schedule, a nice responsive UI with dockable tabs. So thanks so much to the MakePad contributors for that. And we do have, in a different project, some local LLMs that can be run to do, any variety of different tasks. But one thing that would be cool would be something like what Discord does with these automated topic analysis or like chat summaries. So I'll talk about that in a moment. So the first step, of course, is to reach feature parity with existing clients. I think this is self-explanatory, so I'll skip it. And then this multi-pane dockable tab UI, you already saw that. This was our initial design prototype. And as you can see, this is the sort of thing that you can have with multiple different rooms. And it's really nice. So I already demoed that, so I won't go into too much more detail about that. Okay. And then come the cool AI features, right? So what can we do with this? So Motion is a separate project. I think it's now called Molly, not exactly sure, MoFA. And these are basically ways to have a local LLM run and do things with the context that you pass it, right? So currently it's basically a chatbot, kind of like LM Studio or ChatGPT, but we could integrate this with Matrix and do so in a way that is safe without giving all of your encrypted Matrix room information to a remote service, right? That's the benefit of doing this locally, right? So this wouldn't jeopardize that end-to-end encryption that most Matrix users value quite a bit. And you get to retain data sovereignty because everything happens locally, right? And you can still get, you can still take advantage of these neat little features, like asking the local LLM model, model to do something like summarize the last 1 week of topics that you missed after you came back from vacation, for example. All right. So I'd like to explore this in more depth. We already have a lot of other folks working on some of these AI LLM integrations. So I think this is ready to go. It's just a matter of doing it. And then longer term, we can even use Matrix as a platform to share some of these recipes that could help others more easily start to integrate LLMs into their local chat client or their open source projects. For example, you could have a chatbot that would answer questions about your GitHub repo in a public way on a Matrix channel that would allow other people to view it. So that could be a pretty cool use case. So this is how something like that might look for this. Okay, yeah, so you have maybe a sidebar, which we already have UI support for, where you're running a local chatbot and I'm saying, hey, please summarize the last few days of conversation from this room. And then the Robrix client itself can provide that context in that information as context into the model and then run it locally without any fear of your encrypted data being, I don't know, saved by ChatGPT or something. Okay, so in the last couple of minutes, I have 5 minutes left, all right? Okay. Sorry, I got too much stuff to get through. Stage 3 would be expanding this beyond just Matrix. All right, so we'd like to have a community hub. Matrix is the start, right? That's a nice peer-to-peer discussion protocol, real-time chat. And then we could have other things like microblogs through Mastodon and other ActivityPub services. We could have community forums like Lemmy, which is sort of a federated Reddit. We could have other things like source code views and so on, notes, whatnot, etc., news feeds. And then because we have all of these sources of data centralized in one app context, we're able to, show you a nice little notification pane. I don't know about you guys, but my GitHub notifications get out of control. So this could be a nice way to, simplify and centralize all the things you need to be aware of after you've come back from vacation or a conference. Right, so the idea is we could collect all of this into one app, and then not only would it be convenient, right, but you could do powerful combo features. For example, like what WeChat has through its mini programs, you can have multiple different integrations, and you can use some of the WeChat context, like your ID or something, to authenticate with a particular new service that you've never used before. Another thing that we'd like to do is to explore greater the whole concept of decentralized ID providers, and there are a few talks on this topic tomorrow morning, I believe. So I encourage you to check those out. And we'd like to use Robrix as kind of the first experimental testing ground for getting one of these decentralized ID provider services or a wallet service integrated with the Matrix spec or with the Matrix authentication service. Right, so you could talk to a wallet and then have it provide the ID context back to the app and then have the app share that with whoever you permit. Okay. Right. And there's a whole bunch of other service categories, but in the interest of time, I'll move past those. I think we already have enough on our plate, but that's sort of the long-term plan for Robrix as an experimental test ground for using next-gen internet services. Mostly we want to just make it a little bit easier for you to use and discover these decentralized services, as it can be harder to find those and set those up and kind of understand the distinction between a home server and where your account is hosted and how to move them back and forth. These things can be sort of a barrier to entry for new people to get involved with decentralized services. That's pretty much it. Before I go, I just wanted to acknowledge some of the great contributors and collaborators that I have, specifically a lot of the MakePed team. They're all back there in the room, and other folks from YWorks and Uruguay and FutureWay and other people throughout the globe, all making this possible. So thanks very much to them. If you're interested in Robrix or you'd like to contribute or try it out, you can find us here. This is a QR code to the GitHub page. You can also hit me up on Matrix itself. There's several different rooms and spaces, or you can find me in most platforms at the @KevinABooth handle. Thanks very much.